Okay, gentle people, let's go ahead and tackle this problem out. So the first thing we have to realize is we're going to use an ice table. Now, since we're after Kp, the best thing to do is to put everything in terms of ATM. So that's what I'm going to do with all of the values that they gave us. So I'm going to start out with PCl5. We have 2.4156 grams of this substance. So the first thing I'm going to do is change this into moles. So I'm going to look on my periodic table and get the masses of every single one of my elements. So by dividing by the molar mass, I get 0.01160 moles of PCl5. Now the reason I got moles is because I can use the ideal gas law to convert this into a pressure. So PV equals nRT. We can go ahead and solve for pressure, and we can go ahead and insert our values. Be sure to put your temperature in as Kelvin. So we're going to take that 250 and add 273 to get 523 Kelvin. Once you put in all your values, you can go ahead and crank out that calculation. And what you should get is a pressure of 0.2489 ATMs. Now, there's one other thing we should convert to ATMs, and that is the total pressure. The total pressure, and remember, this is going to be at equilibrium, is 358.7 torr. So I know that 760 torr equals 1 ATM. So the total pressure is going to be 4720 ATMs at equilibrium. Now that we've got all this, we can start our ice table. So I'm going to go ahead and write down the reaction that we are interested in. So we have a decomposition reaction, and I'm going to create two gaseous products. And we should note in this reaction, all of my substances, reactants, and products are gases. So I have I, C, E, and we can go ahead and plug in our values. So we calculated out what our initial pressure is going to be, 0.2489 ATMs. We don't have any PCl3 or Cl2 gas. So in this case, there are no products here. So the change is going to create products, and I'm going to consume reactants. Everything is in a 1-to-1 ratio, so X's across the board. So I get 0.2489 minus X, X, and X as my equilibrium pressures. Now what we can do is we can go ahead and use the total pressure. So remember, the total pressure, and this is the pressure at equilibrium, is 0.4720 ATMs. Now, the total pressure are going to be due to all the gases present at equilibrium. So at equilibrium, I'm going to have the pressure of PCl5. I have the pressure of PCl3. And I also have the pressure of Cl2. These are all gases. But I have an expression for each one of these pressures. According to my ice table, the pressure of PCl5 is 0.2489 minus X. The pressure of PCl3 is X, and the pressure of Cl2 is X, and this all equals that total pressure. So I can go ahead and solve for X, and in this case, X is going to be 0.2231 ATMs. Now what I can do is I can go ahead and rewrite E, my equilibrium pressures, by plugging in X. So I can take that 0.2489 minus X, and X is going to be 0.2231, and what I come up with is 0.0258 for the pressure of PCl5. For PCl3, it's just going to be the value of X, so this is going to be 0.2231, and then finally Cl2 has that X value as its pressure, so it's 0.2231. Now with the equilibrium concentrations, I can calculate Kp. it's going to be my products and their pressures divided by the pressure of my reactants. So if I go ahead and do this calculation out, I get 1.929 as my Kp. Now we're going to use this value for part B. Now for part B, we have to do a quick calculation. So again, we want everything in terms of pressure. So we're going to start with PV equals nRT. So in part B, I can rearrange the ideal gas law like I did in part A, and I can go ahead and plug in my values. So 0.25 R, and again, we're at that same temperature, so remember to keep this in Kelvin, and we're going to divide by the same amount of liters. So the pressure is going to be 5.365. And so remember, we're adding this many moles of chlorine gas into our system, which is at equilibrium. So now what I can do is I can go ahead and say that my pressures are additive. So I'm going to go ahead and look at what my previous pressure of chlorine gas was. And in this case, it was 0.2231. That's what we calculated in part A. And so my new initial pressure of chlorine is going to be this. So this is going to be the pressure of Cl2 once I do my next ice table. So we're going to go ahead and rewrite our chemical equation. So here's my equilibrium. And so what we have to do is fill in a new ice table. Because what happened here is that my system was at equilibrium. I added an amount of chlorine gas, and so if I added an amount of chlorine gas, I'm no longer at equilibrium. And so what we can do is we have a new ice table to evaluate what is going to happen to reestablish that equilibrium. So I'm going to go ahead and place values in. So I'm going to look at part A, and I'm going to write down the pressure of PCl5. I'm going to also write down the pressure of PCl3 that I got from part A. And now I can write down the new pressure of chlorine gas after I add that extra chlorine gas. So now I can go ahead and do my ice table. So understand what happened here. I was at equilibrium, which means I had the perfect amounts of reactant and product. I put more product in there, that's Cl2, and so now I have too much product. So that means I am going to start to consume my products. If I consume my products, I'm going to make reactants. And so I have a ratio of 1 to 1 to 1, so my change is going to be plus x minus x minus x. Now we can go ahead and do I plus C equals E, and I get my equilibrium amounts. So now what I can do is I can set it equal to my Kp. So I'm going to do the same thing I did last time. I'm going to put my products divided by my reactants, and I'm going to set this to a Kp value. Now in part A, I calculated that Kp. You guys can scroll up and see that this was 1.929. And remember, Kp stands for equilibrium constant. So this value right here is constant. It does not matter where you start from in your equilibrium positions. I can start with all reactants, all products, sum of each. As long as the temperature is the same, that value is going to be the same. So the next thing I can do is I can go ahead and FOIL the top of my fraction. And I can go ahead and also times both sides by the bottom of that fraction. Now what I can do is I can go ahead and distribute this, and I can combine like terms to get my polynomial. The polynomial that you should get is x squared minus 7.74 plus 1.1972, and this all equals 0. This leads to an x value of 0.1579. Now the other x value is something that's 7.5, and you'll note that that does not make reasonable sense because you would have gotten a negative pressure, so we can go ahead and throw at that value. So now what we can do is calculate our equilibrium pressures. So for PCl5, it's going to be 0.0258 plus 0.1579, which is our x value. And this should get us 0.1837. Next, we're going to take 0.2231 and subtract our x value of 0.1579, and we'll get 0.0652. And then lastly, 5.588 minus the 0.1579. And this gets us a value of 5.4301 as our equilibrium pressure. All right, I hope that made sense.